So the next topic in this intro is to evaluate the different Java programming paradigms, some of which we've covered in this class, some of which we're about to cover in more detail, some of which I expect you know from previous courses you've taken, either in Java or other languages for that matter. So we'll see here that we're going to compare and contrast the object-oriented approaches, and then the synchronous and asynchronous functional approaches, and then the reactive programming model. And we'll talk about the pros and cons of this stuff. So here's a nice little table I put together that kind of gives you a bird's eye view of the different paradigms, and we organize them across different axes. So single value, multiple values, and synchronous and asynchronous. Those are the two axes, and then everything else just kind of falls into the right place in that fourfold table. So the classic way of programming Java, your grandfather's or grandmother's Java, depending on who was programming Java in the mid-90s, was using object-oriented techniques where the calls were largely synchronous. You make a call on a method and you wait for it to come back. When it returns, the control flow comes back to you. And you would get a single value in return. Now, it could be a value that was an object that had fields, but it was one thing that came back. And here's a very simple example where we've got a download content method that takes a URL, and it goes ahead and it opens up a connection to the server designated in that URL, and then it reads the contents from that connection and stores them in a buffer that it returns back to the user. So very classic object-oriented approach. It blocks, one value comes back, it's synchronous. And this has long been sort of, for the last 10, 12 years, people have been like poo-pooing this because it kind of sucked and you had all the problems with platform threads and all kinds of stuff like that. However, virtual threads and structured concurrency are making synchronous programming cool again, because now you can use this approach, which everybody pretty much has grown up with if they learn to program in a 101 style course, without having to incur all the downsides with platform threads. So virtual threads and structured concurrency are making synchronous approaches more acceptable. And some people will argue that they're going to dominate once again very quickly. Another approach is to have synchronous computations, just like we did with objects, but allow multiple values. And of course, that would be the streams model. And in fact, the parallel streams model basically says, I'm going to take a bunch of inputs, and in parallel, I'm going to apply various operations on them. I'm going to filter them, I'm going to map them, I'm going to flat map them. When I'm all done with all those filtering and transforming operations, I will collect them together into some other data structure like a list, and I get back multiple values, either multiple values in the stream or multiple values when we're done by collecting them into a list. So that's multiple values. So synchronous, multiple values. This model, I like this model a lot. I think it's easy to learn, and once you pop your brain into it, it scales quite nicely. So it's got a really good balance between performance and ease of use, ease of programming. Another model, which was also popularized when Java 8 came out in 2014 timeframe, is completable futures, where we still have a single value. We get back a completable future, just one of them, but now we can do our computations asynchronously. And so you can go ahead and create asynchronous computations by registering actions that will run in some background thread in a pool, for example. And then as the background operations complete, you can chain together a pipeline of so-called completion stage methods that do their processing with respect to what happened before. So you kind of get a synchronous programming look and feel, but the actual computations are taking place in the background. So that's asynchronous single value. You can then go one step further, and you can combine streams and completable futures. So you can have the control flow managed by a stream, as we show here, but then you can have the computations taking place asynchronously using completable futures. And that's also a pretty cool approach. The nice thing, you can stay within the pure Java paradigm, and you get nice speed up, and it's relatively easy to program. But it's a little bit, some people don't like it because it's kind of a hodgepodge of two different things that are used together. I happen to like it a lot, but I'm probably like one of the few people who thinks that's great. So now we're moving into the world of multiple values, because we've got streams again, but asynchrony. So streams plus completable futures is kind of the homebrew approach of trying to get close to reactive streams. And then, of course, the final approach here, which we show in the upper right-hand corner, is reactive streams. And reactive streams is, once again, multiple values because we had a stream of stuff. It's asynchronous because things can run in the background. And if you play your cards right, you can get fairly clean code by using abstractions like parallel flowables, which is what we show here. Whoops. Or I guess I forgot to show the other slide. You can also have parallel fluxes that look pretty much the same way as the flowable type of approaches. I'm sorry, the parallel flowable approaches. So the main difference between this approach and this approach is this approach combines two things together. This approach has one unified programming API, as vast as it may be. So this is the reactive approach. So that's kind of where we are at this point in terms of the evolution of Java programming. Now, let's talk about the pros and cons of this stuff, because it's not all unicorns and rainbows, of course. So there are some benefits, which is a good thing. Otherwise, we wouldn't spend time learning this paradigm at all. One nice thing about this is you can have concurrency, actually very scalable concurrency, with a minimal number of threads by using a range of thread pools. These are the ones you get with RxJava, but you can use the same type of thing with Project Reactive. What this leads to, why would we do this? It leads to better performance with fewer resources. And the whole idea here, again, think this was a time when traditional Java threads or platform threads were the only way to do things. If you used the conventional approaches, which were done synchronously, as the load went up, the performance typically started to crater at some point because you've got way more work going on and you have too many threads, or you have a bunch of threads that are just sitting there blocked and not doing anything. And so the performance tended to not scale very well, whereas a reactive approach would scale better. That was the sales pitch, and it was actually true. Another nice thing about using reactive programming is you very rarely need to do any explicit synchronization, and you very rarely, if ever, need to spawn threads directly. That's all handled by the frameworks. And this helps to alleviate accidental and inherent complexities of concurrency and parallelism, because you don't have to deal with these issues. Instead, they're handled for you at the infrastructure framework level. To be honest, however, these benefits are not unique to reactive streams. So structured concurrency gives you some of the same benefits as does parallel streams, as does the completable futures. The goal is to try to avoid having to deal with a lot of explicit threading and locking. You abstract those things away into little frameworks, which is nice. However, there are some downsides, and one of the tricky parts, one of the real knocks against reactive programming is the learning curve. So if you're doing a very simple thing, reactive programming can be overkill because you have to learn all these asynchronous APIs, which makes your brain do somersaults if you're not familiar with that paradigm. And where the benefit comes is you have more and more complicated systems where you really do care about scalability. Then you get a win, because the traditional approaches historically didn't scale up, whereas the approaches with reactive programming, at least in theory, would, if you were willing to take the time to learn it, which is one reason we're going to learn it here. So you'll be equipped if you so choose or end up in a situation where you have to do this kind of programming. So to really win, you've got to figure out a way to be productive, because if you're not careful, performance will be high, but productivity will be lower because you won't know what you're doing. So that's why we're going to study it. However, there are other perspectives on this, and there's a great video. You can go watch this video. You can get it at this link. This is the time, the number of seconds into it where this conversation takes place. The interviewer is asking Brian Getz, who's one of the chief architects of Java, who works at Oracle, what's the future of reactive programming in Java going forward? And his point, which is a somewhat biased point, but I don't necessarily think he's wrong, is that Project Loom, which is this structured concurrency virtual thread model we've talked about, is going to kill reactive programming. And I think that's probably a little strong, but I do think what will happen is people who use Project Loom will be able to stick with the traditional synchronous programming model that we've come to know and sometimes love and sometimes hate with Java, without having to incur all the downsides with that traditional model, because they will have re-architected the threading infrastructure under the hood so that we'll be able to program productively using, quote, more intuitive ways of doing things. Now, the reason they're more intuitive, honestly, is because that's what most people started learning. And so the reactive model is a, quote, newer paradigm, and it does take a while to get your head around it. But the whole point of this class is to give you the tools to make your choice. So you'll be able to program in any of these paradigms, and at least until ChatGPT takes all of our jobs away by being able to instantly transform into whatever language or formalism we want at a drop of a hat correctly and verifiably and so on. You still have a choice to make, and this will give you an opportunity to make an informed choice. So I will let you decide whether you like one approach versus the other. I personally don't really like Java structured concurrency. I think it's way too much ceremony for what you get. But I seem to be in a minority about that. So I will continue to be very proud. That's probably why Justin Bieber is a lot more popular than the bands I like Rush, right? Because most people tend to like a simpler form of music and not the more sophisticated stuff.